Hey guys, this is Zach. Today we're going to be doing chapter 2.1 of functions. So first we have to define what a function is. And a function is an equation that, or a system that when you put in a value, it gives you a return value. So if you plug in x, you get y. So to differentiate between a function and something that is not a function, the simplest way to do that would be to look at your graph. So say you have a line like this, and you do what's called the vertical line test, which is you draw a vertical line down any point of the graph, and it should only touch one point. Like here, 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 and here. It only touched one point. If you, for example, if you had the equation x equals y squared, your equation, your graph would look something like this. If you did the vertical line test, it's that each vertical line is touching the graph in two spots rather than one. So this is not a function, whereas this is a function. Another way to look at it is if you're given a table. So if you have a table of x and f of x, and you're given, say your values are 1, 2, 3, 4. I'm just making up an equation, but a trick they'll do is they'll give you, if you plug in 1, you get 2. If you plug in 2, you get 2, and then this could be like 4 or 8 or something. And you'll see two y values, and you'll say like, oh, that might not be a function, but it is a function because you can repeat y values. However, you cannot repeat x values. So if I had 2, 2, 3, 4, and I had 1, 4, 6, 8, I don't know. If you repeat these, it's not a function because each x value has to give you like a new y value. So you can't have, like if you graph this, you have at x equals 2, it would equal both 1 and 4. And therefore you wouldn't pass your vertical line test. So you can't have two values, two of the same x values. But you can have two of the same y values like this. Next we're going to do domain. So the domain of a function is actually pretty important because it tells you which values of x, or your independent variable, which values you can plug in, like which values will actually give you a return function, or y. So each function has a specific set of independent variables or independent values you can use. So if you had the equation y equals x squared plus 5x, you know here you can plug in any value of x and you will get a value for y. Everything you plug in will work. And so the domain here we say is all real numbers. That symbol means all reals. So that means any real number, meaning it's not imaginary, you can plug in for x and get a response of y. So that's scenario number 1. Number 2 would be if you have a fraction. So let's say f of x equals 3x over x squared minus 4. So here your domain has to be, the only thing that will not give you a return value for y is if you have the denominator equal to 0, because a number divided by 0 you can't do. It's not a function. So what you do here is you set the denominator, x squared minus 4, equal to 0. And so by doing that, you solve for x, so x equals 4, or you could set it to not equal. So just put a line through it. And then take the square root of both sides, and so you get x cannot equal plus or minus 2. Root 4 is 2. So you know, so the domain would be all real numbers except for x cannot equal -2 or +2. So that makes sense, because if you plug in -2 or +2 for x, you will get a denominator of 0. The third scenario would be if you have a root in your function. So if you had the function f of x equals root 4 minus 3x. So here, you can't have the radical be less than 0. Like, you can't have a negative number in the radical, because it'll give you an imaginary number. And since we're only dealing with reals, you can say the domain is 4 minus 3x has to be greater than or equal to 0. So that basically means it can't be negative. So you can move, so you have -3x has to be greater than or equal to -4. You divide by -1. And then you get 3x. 3x is, switch the signs because you divide by negative, so it has to be 3x is less than or equal to 4. So divide by 3, so x has to be less than or equal to 4/3. And so that's your domain. You can write it x, and then this line means x such that x is less than or equal to 4/3. So now we're going to learn how to work with when you have two functions and you're either adding them together, subtracting them, multiplying, or dividing. So if you have two functions, f of x, and you have the function g of x, and you just need to know that if you get a problem in this format, f plus g and then of x, separately, that's the same thing as f of x plus g of x. So that means the same thing. So if you see this, then just separate it out into this and you add these two functions together. So add f of x and add the components of g of x. Now the next one would be if you have the same thing, f minus g of x. That's the same thing as f of x minus g of x. So you just subtract the two functions. So it's really simple, but you just have to know that that's what that format means. So then the next format would be multiplying them. So if you see f times g of x, just know that that means f of x times g of x. And if you see f divided by g of x, it's the same thing as f of x over g of x. So you just divide the two functions. However, the catch to this one is there is a domain that g of x cannot equal 0, because then you can't have the denominator equal to 0. And so for all of these, the domain is this is both the functions together. So what that means is if you have the function, say f of x is the domain is x cannot equal 2, and say g of x, the domain is x cannot equal 3 and it cannot equal 4. So you would say the domain of this function is x such that x cannot equal 2, 3, or 4. So it has to incorporate the domain of both the functions. And that's true for all four of those cases: adding, subtracting, multiplying, or dividing. So let's do an example from page 68, number 69. It gives you the function f of x equals 2x plus 3 over 3x minus 2. And then g of x equals 4x over 3x minus 2. So these are your two functions, f of x and g of x, and then part A of this asks you to add them together. So it says f plus g of x. And so you know that that format means you're just adding the two functions together, and combining their domain. So first of all, you need to know the domain of both functions. So, for this one, the domain is that 3x minus 2 cannot equal 0, 3x cannot equal 2, x cannot equal 2/3. And then you can see they both have the same denominators, f of x and g of x, so they both have the same domain. So that's just your domain. It incorporates both of them. So that's your domain of this new added function. So you just have to add the f of x and g of x together. They have common denominators, so you can just combine the numerators. So 2x plus 3 plus 4x over the common denominator of 3x minus 2. And then you can add the x's together, so you get 6x plus 3 over 3x minus 2. And they'd probably ask you for the domain as well, and you could say the domain is x such that x does not equal 2/3. And that's your answer to the problem. Now part E wants you to plug in an actual value, so it'll give you f plus g of 3. And so what you do here is you add the two together, but you also plug in 3. So we already got that this one equals 6x plus 3 over 3x minus 2. So you just plug in the value of 3, so 6 times 3 plus 3 over 3 times 3 minus 2. And so you get 18 plus 3 is going to be 21 over 9 minus 2 is 7, so your answer is 3. And then the domain is going to be the same because it's the same function. And then lastly is the range of the function. So the range is just the lowest point to the highest point. So if you had a function that goes up to 4 and then it goes down to 2, so like that. So the lowest point is at this line right here, so when y equals -2, and then the highest point is up here, and that's when y equals 4. So you would say the range of this function is from -2 to 4. And so that's not as important as the domain, because the domain actually restricts what you can use in the function. The range is just telling you the output that you can get. So this function, for any value of x you plug in, the range is telling you that your output, your answer, is going to be between -2 and 4, because that's all the function can provide you with. So that's it. Next we'll be covering even and odd functions, which deals with symmetry. And so we'll get more in depth with functions.